In section 9, we're going to continue to talk about systems of linear equations, but we're going to be working on a three-variable situation. So we're going to be taking the line, which we know a line in two-dimensional space looks something like this. Two-dimensional space is just a flat plane space. And we're going to be taking the idea of the line and we're going to be translating it and extending it into 3 dimensions. So when we extend it into 3 dimensions, we're going to end up getting a plane. So what you see here in front of you is a plane, and there is a x-axis, there's a y-axis. I'm going to put a little dot here, and then the y-axis you can see after that. So the plane is actually hiding part of the y-axis there, and then we have the z-axis that ends up going straight up. And this gives us a 3-dimensional rectangular coordinate grid for us to be able to plot things 3-dimensionally. Now the good news is I'm not going to ask you to do any plotting in 3 dimensions here, which means that we will not be doing any graphical methods for linear systems in 3 variables. But I wanted you to see what a 3-dimensional line looks like. It is a plane. And the equation, you'll notice, has not just x and y, but it also has z. And I know that we were told that a linear equation has to be of the form y equals mx plus b. Now that's true if you have just 2 variables. But what I want you to notice about the y equals mx plus b format is that the y is to the first power and x is also to the first power. And when you look at the equation that I have here, for example 9.1, x is to the first power, y is to the first power, and z is to the first power as well. So this is how we can recognize that we have a linear equation in 3 variable, or 3 dimensions, if you will.